Okay, now we have something a little bit different. Here we have Tar Baby mounted in its enclosure, and we're using one Q1 MOSFET and two Q2 MOSFETs because that's all I have left after the disaster that blew out 5 perfectly good IRF-PG50 expensive MOSFETs. So there they are down in the box, and they're hooked up to Tar Baby as usual. The bias source is coming from the pot dropping resistor and the L&Co power supply, and then over here I have the different thing. Let me take this off here for a moment. So what we have there is a capacitor bank of 7 well, there's 6 48,000 microfarad capacitors and one 60,000 microfarad capacitor in there. So that all together gives an approximate capacitance of 350,000 microfarads, or a little bit over 1/3 of a farad, at 40 volts DC. Unfortunately, these are only 40 volt capacitors in there. So I'm limited to 40 volts of operation. So, and what this is up here is this is just my voltage and current metering system, and because I'm out of room, I have to just set that down on top of the capacitor bank like that. Okay. So this looks a lot more complicated than it is, really. What I have is the negative supply lead from Tar Baby, which is the green one coming over here, and it's not hooked up yet. Okay, and the positive supply lead from Tar Baby, or to Tar Baby rather, is going to the positive of this capacitor bank. Okay, and then this wire over here is the voltage monitoring wire and the voltmeter. Okay, and then the negative side of the capacitor bank goes through this wire here to the current meter and the voltmeter, so that gives us a connection for the voltage across the bank. And then from the current meter I have another wire, this wire, coming over here, and then this will be hooked to the negative wire of Tar Baby supply, completing the circuit when I'm ready to run. So we're monitoring the voltage across the battery pack or capacitor bank, and we're looking at the current going to Tar Baby from this setup as usual. And over here I have 3 batteries, because we can only use 36 volts. This is only a 40 volt capacitor bank. So 3 batteries gives us 36 volts, and they're not hooked up to anything else, anything right now, right? So here's, down here, there's a red clip lead to the positive of the capacitor bank. And then I'm going to take that red clip lead, hook it to the positive of the battery bank. Let's go through the fuse just in case. Okay, now here I have a 50 ohm dropping resistor to limit the charge rate as I hook up this other lead from the negative side of the capacitor bank to the battery. Okay, so that's what I'm going to do. I'm just going to hook the capacitor to the battery, and it's all in parallel, so the capacitors will charge up, and then I'll show the voltage on the capacitor building as it charges. There won't be anything showing on the current because the current is not in this particular loop, but we'll be able to see the voltage building on the capacitor bank. So here we go. I'll hook it up through the resistor first, like that. Now we'll watch, see there? Now we'll watch the voltage on the capacitor bank build. It's charging, the current is limited by that resistor. If we just hooked it up directly to the battery, it would be like hooking up a direct short right at first as the capacitors charge, because they have very low resistance when they're first charging. So once we get up to 28 volts or so, we'll go ahead and that resistor's pretty warm, so we'll unhook it from here and hook it to here. See that little spark? And then we'll complete the charge. From there it charges very rapidly up to the battery voltage. Okay. There's no resistor in there. Alright, so now we're at the battery voltage of 37.2 volts or so, topping off the rest of that charge. So now the battery pack is in parallel with the capacitor bank. The voltmeters are monitoring the voltage on the whole system and the current through the whole system, and I have not yet hooked up the negative supply lead. So first let's make sure we got the bias supply turned all the way down. Now let's find the negative lead in all this garbage here. And we'll plug it in like that. Okay. So now over here, let's see, battery voltage. Remember where the baseline is, right down here. So there's the baseline. So there's the battery voltage, just under 40 volts, 37.5 volts. And then this is going to be the current viewing resistor up here. Okay. So now let's go ahead and give it some bias current. And as you can see, as soon as we bring the bias up, the oscillations come on very nice and strongly. That's only 50 milliamps of current through the system. Let me get the trigger on there. There we go. Okay, now remember where the baseline is for that, right? The baseline's right across here. That gradical marker right there is where the baseline is on the current viewing resistor. So this is going to give us a strong negative going power product again. We have all this area underneath showing the negative current, and then the positive humps on the battery voltage there, right? Let me get a little bit more magnification on that. Okay. Let's leave it right there. All right. So now, what comes next? Well, yeah, let's turn up the bias current a bit. Okay, turn up the bias current till we have about 100 milliamps through the system. Load's heating. Oops. Using the load to prop myself up there. I knocked loose one of my ground wires. There. Okay. So there we go. We got nice, strong negative power product there. Right? Look at all that area, all that negative area, and then all that positive area that it's going to be multiplied by. So that's going to give you a strong negative power product right there. Alright, now you know what comes next, right? I'm going to unhook the battery. Okay. Unhook the battery completely from the system. Now we're running on the capacitor bank alone, and you can see that the voltage is dropping, right? But you can also see that the oscillations aren't going away, not very quickly, and you can also see, I hope, that we still have a strong negative power product happening in there, right? So, oscillations, let's just change the, there, look at that. How's that for oscillations? Okay, and yeah, the voltage is dropping, but an appropriately sized battery pack can sustain the current through the system for a long time. The oscillations collapse over a period of time, but certainly not immediately, and they certainly continue to show the strong negative power product for quite some time as the voltage drops. All right. Okay, so they're now finally at about 16.5 volts. We finally lost the ability to actually produce and sustain the oscillations. They're gone. All right. So Tar Baby runs, heating the load, 3 total transistors, no battery pack, only a 1/3 farad capacitor bank charged to 37 volts. Thank you for watching.